Hello everyone. Today we will start finite difference part 2. So first we should know fundamental theorem for difference calculus. The statement is if fx be a polynomial of degree n, then the innate difference of fx is constant and n plus 1 difference vanish. That means 0. So what is Newton-Gregory formula? The result is f of x plus n is equal to e to the power n fx, and that we can write 1 plus del to the power n fx. So 1 plus nc1 delta plus nc2 delta square plus nc3 delta cube plus dot 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 ncn del to the power n whole fx. And that we can write in short form f of x plus n is equal to summation I equal to 0 to n nci del to the power I fx, which is known as Newton-Gregory formula. Next is finding polynomial. How to find polynomial of second order or higher order, that means third order, fourth order, fifth order may be possible. So first we will find, this is strictly for second degree polynomial. This is not applicable for third order or higher order. This is strictly for second degree polynomial. From the following table, find the polynomial fx, and these are the values of x and fx are given. Here is the table. So first we have to find the difference table. X, y, del square y, del cube y. So 0, 1, 2, 3, 4, and here 3, 6, 11, 18, 27 that we here put. Now first we have to find the difference table. So 6 minus 3, 11 minus 6, 18 minus 11, 27 minus 11. Same way del square, 5 minus 3, 7 minus 2, 7 minus 5, 9 minus 7. So 2, 2, 2 and here 0. So what is the reason to take the degree of polynomial? So first we can check here, these three values are same, that means del square y is constant and del cube y is 0. So fx is a polynomial of degree 2. And for this reason, here we can assume y equal to fx equal to ax square plus bx plus c, where a, b, c are constant to be determined. So how do you find? So first we will find out, here we are going to find three values, so three equations we need, because in number of equation number of unknown should be same, then we will find the unique solution. So putting x equal to 0, 1, 2, 3 dot 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 in equation 1, so the left hand side it will be y0 and the right hand side it will be, and right hand side is equal to, at the point of y0 the value is 3. So 3 equal to ax square. What is the value of x here? 0. So a into 0 plus b into 0, that means c equal to 3. Now putting the value of c equal to 3 in our equation, like a plus b equal to 3 and y2 equal to 11. So 11 equal to 4a plus 2b plus c. So there is two equation, 2a plus b and equal to 4. So we will get, after solving these three equation, a equal to 1, b equal to 2 and c equal to 3. And the final polynomial is y equal to x square plus 2x plus 3. So this is for second degree polynomial. Next we will move to third order or higher order polynomial. So first, same as before, we have to make the difference table. So 1, 2, 3, 4, 5 difference table values are, and fx equal to 4, 13, 34, 73, 136. So same way in the previous model, previous problem, we already found how to found del square y, del cube y and del to the power 4y. Already we put. Now we have to find out, first we have to understand what is the degree of polynomial, then we will go for the remaining process. So as for the previous theorem, fundamental theorem of difference calculus, just see del cube y is constant. Now you can tell me what is the meaning of constant. So just see they are the same value. So since del cube y is constant and del to the power 4 by 0, so fx is a polynomial of degree 3. Okay, so here degree 3, that is confirmed. Now how do you find the calculation? We know that f of x0 plus n is equal to e to the power n f of x0. This is from shift operator, and this is equal to 1 plus del to the power n f of x0. And this is the relation between shift operator and forward difference operator. So here these are the very common values. Here x0 equal to 1, h equal to 1, x0 plus n is equal to 1 plus n equal to x. So n equal to x minus 1. Now actual the formula fx equal to 1 plus delta whole to the power n f of x0, and this one formula as written as 1 plus nc1 delta nc2 delta square nc3 delta q plus dot 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 into the power 4 delta 4 plus dot 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 into outside f of x0. This is the calculation part. Okay, so first we have to put the values of x and y. Okay, and next then we have to make the group. Okay, because if we want to go to for multiplication, okay, so this is not possible to come, so that's why we have to handle tactfully, and there within few lines it will give you the answer. So after putting all the values here, we can check. In the first equation we have one function x minus 1, second one 2 function, and third one 3 function. Okay, so after this taking common this and by calculation you will get the answer. This one the answer x cube plus 2x plus 1. Another part is there. Find the value of the polynomial when the f of 1.5 is like this for checking. Next is missing term. Missing terms, what is missing term? So missing actually whenever we are going to find the missing terms, so here one value will be missing and we have to find out the corresponding missing frequency. Here is the missing frequency. So now question is how do you find this value? So first is here we have to check how many values are given. So we can say that easily 1 2 3 4 values are given. Okay, so your degree of polynomial 4 minus 1. Okay, degree of polynomial 4 minus 1. We have to check how many zeros are there in the last row. Okay, so here since fx has 4 given values, so we assume that fx is a polynomial of degree 3, and here for the degree of fx is vanishes. That means del to the power 4 fx equal to 0, this one, and we know that relation between delta and shift operator, this one equal to e minus 1. Okay, so e minus 1 whole to the power f4 f of x0 and e minus 1 whole to the power 4. How do you formulate e minus 1 whole to the power 4? Okay, so 4c1 like this, 4c0 e to the power 4 fx, and 4c3 4c1 the like 4 into e cube fx. So in this way you will use the formula, and again how to get from this one to this one. We know that e to the power n fx equal to f of x plus nh. So same way according to value of n, this n is changeable. Okay, so at the last line here one h is there, so since here 0 to 1 h is 1, so h equal to 1, so f of x plus 4 minus 4 into f of x plus 3 plus 6 into f of x plus 2 minus 4 into f of x plus 1 plus fx equal to 0. So now coming to the end of the problem. So first, since here 3 unknown we need, so we will put x equal to 0 and x equal to 1. Okay, so here x equal to 0, after putting x equal to 0 we have f4 minus 4 f1 equal to 12. Okay, so again we will put x equal to 1, and after this we will have 4 into f4 minus f1 equal to 93. So we have two equation 1, here equation 2. After solving this, we will get f1 equal to 3 and f4 equal to 24. So here is the all about finite differences part 2. In next class we will start with interpolation. Okay, so till then, okay, bye bye student, we will meet again in our next class.